Good morning, everybody. How are you? Hope that you're doing well. Hope that you and your family are good out there on this beautiful Sunday. Or at least I hope it's a beautiful Sunday for you. It's a beautiful Sunday out where I live. But thank you so much for joining me for our always continuing discussions on data science and everything related to that world. If this is your first time joining us, welcome. I'm still getting a lot of new users across all of my platforms. So glad to have you here. Hopefully you can find the discussion interesting and beneficial to you. On Sundays, I tend to have a little bit more of a structured discussion than what I would usually do. So thank you so much for being here. I think it's going to be a very interesting talk today on building an API. I think it's a topic that doesn't get a lot of attention, and hopefully I'll give you some of the basics. Hopefully I'll do justice to the topic because I think there's a lot of very interesting things in this topic, so we'll have to see where we end up. So before we go much further, I want to make sure that I finish up all of my promotional materials and all of my final notices. I'm seeing quite a few people on Instagram, which is fantastic. So welcome, Instagram. Nice to see you. On Instagram, I have just pinned a comment that contains the widescreen view over on YouTube. I make that available on Sundays because Sundays we do look at code and we look at different things up on the screen. So some people do find it a little bit easier to look on the widescreen. You're welcome to stay on Instagram, but just a little bit of an FYI there in case you do want to switch over. I just want to do one more thing. I need to get my Twitter side also up and running. So give me just a second here, guys. Let me get this one going. And then I also want to put it out to my Discord. See if people from Discord also want to join in. But I'm seeing a lot of participation already on Instagram. That's fantastic. Thanks so much, guys. So if you're on Instagram, feel free to let us know a little bit about where you're from. We always ask people to kind of introduce themselves. I don't necessarily take a lot of questions on Sundays, but it's nice to say hello, introduce yourself. It's good practice for your professionalism, which is very important in data science. I'm already seeing some people on my Twitch and on my YouTube, so thank you so much. Vibe 1999. Welcome. I think it's your first time. Thanks for being here. Siva, I think it's also your first time, so welcome. Glad to have you here. Anybody else that wants to say hello or introduce themselves, you're certainly welcome to do that. I'm seeing some new people over on Instagram also. And Keith, welcome. I appreciate you being here. I think I see one more. I think, I can't remember what you go by. I think it's Bari, right? So Bari, I know you're not new. Thank you so much for your continued support, my friend. Really, really nice having you here. So glad you're here. Hope you're well. Zerak says, good morning. Hey, Zerak, how are you? Hope you're doing well. Rithvik says, I just graduated from bachelor's. Congratulations. Congratulations on your degree. It's always a good thing to graduate and actually get a degree, right? So let me check one more thing over on my Instagram. Oh, I'm still trying to figure out why my Instagram chat just doesn't want to seem to work with my software, but we'll see. We'll see. All right. So again, if you'd like to introduce yourself, let us know. Otherwise, Sundays, we focus on a tutorial. We're going to talk about an API today. This is a topic that's near and dear to my heart because I think that this is one of those things where you're really able to put some polish on your projects, on your skills, on your delivery of your data science projects. Really important topic. So I'm really excited to see where we're going to end up. Now, I know there's a lot of you who are joining us for the first time. We usually do a series on Sundays. I like to do series, like that carry over from week to week. We've successfully completed 2 series, and they've been pretty big, right? There's the introduction to statistical learning, and then there is the creating a data science project from beginning to end. The first series was 8 parts. The second series was 11 parts. In between those series, I will do like these 1-day tutorials. So right now we're essentially in between series because we just finished the Create series last week. So 11 parts, just really amazing that it was so many parts. So really, really happy that all of us kind of got through that. So this now presents an opportunity to just talk about like these one-off type of topics. And building an API is, to me, one of those one-off types of topics that, you know, are really just convenient for us to look at and to work with on a given Sunday. So that's what I'm hoping to do today. I'm hoping that we can go ahead and tackle this topic, and that way we can kind of take a new dimension to how people will work with our data science projects, right? I think that's really, really important for all of us. Another reason I'm a big fan of this project is because I'm keeping an eye over here on my Instagram. So Ankit says, where do we find the series? Are those as a playlist? Yes, Ankit, they are. They are a playlist on my YouTube channel. You can find it, Data Science with Dennis on YouTube. You can find all of the playlists for everything that I do, but one playlist is called Introduction to Statistical Learning. The other one is called Create a Data Science Project with a Chief Data Scientist. So those playlists are available on my YouTube, okay? And as I mentioned earlier, if you're on Instagram, you're welcome to stay there, or you're welcome to join us on YouTube where you can get a widescreen view. So as I was saying, another reason I'm a fan and really looking forward today to this, fan of APIs, I'm really looking forward to today, is because in some of my other content, I talk to you guys about how you rarely just deliver an algorithm, right? You know, I know that in academic courses and in tutorials, you kind of just develop an algorithm for one task. But that's rarely how it's done in the real world. You don't just develop one algorithm for one task. You are usually consumed by some other application, right? Your algorithm will be used in Salesforce. Your algorithm will be used in SAP. Your algorithm will be used in a mobile app or something else, right? So looking at today's API discussion, I think helps with that, because that will help you understand how you open those gateways or create those hooks, as people say, that help you kind of to make your algorithm accessible to some of these other things, right? Like that Salesforce integration isn't going to happen on its own. You kind of have to do some additional, you know, wiring to help with that, right? So we're going to talk a little bit about that today. And then finally, I'm also hoping that today you'll see some of the benefits of taking an object-oriented approach to your development. Because you can kind of sort of do API layers with a script, but it's probably not recommended, right? It's probably not recommended to do that. And you certainly can't do it with notebooks, right? Today is, you know, if you're somebody who still relies on notebooks, today should be one of those days where you see, okay, wait a minute, I can't replicate that in a notebook, right? APIs are definitely one of those things where you can't just say, oh, let me take my notebook and deploy it as an API. You're not going to get very far, right? So today is going to be one of those days where I'm hoping that you're going to be able to see that. So yeah, so really excited to see where we're going to end up with that. Lots of moving parts today. I have intentionally not done a lot of preparation. Well, I mean, I have prepared some items, but I haven't done a lot of prompting preparation because, as always, we're going to take an AI first attitude, right? We don't have to know all the answers. We just have to know how to prompt our employee, ChatGPT, right? Because we all have an employee now, ChatGPT, that's going to help us to create that code for us, right? No, remember, as I've said before, and I've always said, no code is inaccessible to us, right? We should be working with the understanding that we are capable of writing any code that any code is possible, right? There are no barriers to writing code anymore. So even though we may not have all the answers, I think we can get to the answer, right? So I think that'll be fun. I think it'll be fun for all of us, myself included. All right. Okay, so let me check out the some of the chats. Thank you so much. Go ahead and keep on filling up my chats if you guys like. Don't be shy about introducing yourselves. If you're new, you're probably not the only person, so feel free to introduce yourself. So Vibe99 says, hi, my name is Vibab. Currently pursuing a master's in DS University of Liverpool. 1 semester remaining, no prior experience in the data science field. Okay, cool. Thanks so much, Vibe. So this is a great tutorial for you because this is the kind of stuff that even in an advanced program, you're just not going to get. Nobody teaches this stuff, right? Rex, thanks so much for playing host over there. Anise, our good friend Anise says, hello everyone. Hello Dennis, hope you're having a beautiful day. Thank you so much. What a nice greeting. Yeah, I think we are going to have a beautiful day. I'm having a good day so far. I got up early, took my dog to the dog park. As you guys know, on Sundays, I make my soup. So I got my soup cooking. So after this is done, I'm going to sit there with my soup and my TV shows, and I'm just going to relax for the rest of the day. So I get to have a beautiful day with you guys, you know, starting it off here, and then get to have my own my own personal time. So Siva says it's not my first time I listen to you daily. Oh, wonderful! Thanks so much. I can't. This might be the first time you're introducing yourself, then. But welcome, Siva. Nice to have you here. Yassine, our good friend Yassine says hello, sir. Yassine from Tangier, Morocco. Nice to see you, Yassine. Hope you're doing well. Hope everything is good out there in Tangier. Joseph says, morning, Dennis. Happy Sunday. Hey, Joseph, how are you? Thanks for being here. Joseph and Rex are 2 of my great moderators, so really appreciate them. Happy Sunday to you too, Joseph. Hopefully you're doing well out there in Tennessee. Michael, our good friend Michael from Nigeria says, Sunday blessings, Sir Dennis and everyone. Sunday blessings to you too. I think it's going to be a good Sunday. I think it's going to be very beautiful out where I live. Nice and clear. A little cold out here in the desert. But otherwise, I think it's going to be a great Sunday. I'm going to have my soup, you know, with my onions and my cabbage. Oh, I'm looking forward to that. J Deep over on YouTube. I think it's your first time. Welcome. Hello, Dennis. I'm J Deep from India, software engineer with 12 years of experience. No prior experience with data science. Good to see you here. Well, good, J Deep. Glad you're joining us. Thanks so much for the nice introduction. I'm glad that people with a software engineering background are showing up today, and that may watch this in the future. Because another thing I forgot to mention is that today you're also going to see some of the parallels between what we do in data science versus what's done in software engineering. As I've told you guys before, to me, one of the key parts of data science that I think a lot of people don't really realize is that the closer you get to deployment with a data science algorithm, the more you converge on a data science on a software engineering project. At some point, you cross a line where it becomes they're indistinguishable from each other. Today is some of those lines. You're going to see some of those lines. Because working with APIs is not exclusive to data science. Far from it, right? So if you are somebody who has a software engineering background, then maybe you're going to start seeing some of those items, right? You're going to start seeing some of those relationships pretty clearly. In many ways, you're going to see it just by the fact that we're going to talk about code in a very agnostic way. The code that we're referring to could be an algorithm. It could be just some math formula. It could be written by monkeys. It literally doesn't matter. It literally doesn't matter. So I think we're going to see some of that. So if anybody, you know, attending today does have that software experience, and you feel like sharing that, or you make an observation during my tutorial, feel free to share it, right? Because it's very correlated in that way today. So yeah, so we'll see where we end up with that. But looking forward to that discussion and kind of that feedback from you guys. All right, so you guys know that on Sundays I do my best to try to get started as quickly as we can, you know. So last call for any introductions or any other questions. But otherwise, I think we're ready to go ahead and start looking at the tutorial. So let me start, while you guys think about that, let me start preparing some things on my end. Yeah, I got that. Let me prepare one more thing. But feel free to post any other intros or questions you guys want. I gotta get rid of some of my tabs here. Some of my tabs are hammering my machine. All right. So let me bring up my, I need that. Gonna need that. And I need my, all right. Naaman, how are you? Welcome back. Nice to see you. Naaman says monkeys. Naaman, I use the monkey analogy quite a bit. And I use that a lot because, as I've told you guys before, if you guys watch my content, data science is very near and dear to our hearts. I know that all of us are data science enthusiasts, right? But what you're going to find in the business world is that nobody cares. Nobody cares. They want to know the results of the algorithm. What does it mean to them from a business perspective? But when you try to get into the how of the answer, the how of the algorithm, they don't care. They stop listening. You could tell them that it's some fancy big neural network that took you 10 hours to write. Or you could tell them you got the answer from a room full of monkeys that you trained how to use an iPad. They don't care. So we're gonna end up being very agnostic in some of those ways for us now. Because it really doesn't matter. You know, it really doesn't matter. It matters to you as an individual, right? Because you can take pride in your work, and that's cool. But trust me, I've been in those big boardrooms. I've given plenty of big presentations to very high-level executives. They don't care. They don't care. If I were to tell them, yeah, I got a room full of monkeys in the back that came up with these answers, they'd be like, yeah, okay, cool. Just don't let the monkeys die. And they're not saying that because they're caring people that care about the monkeys. They just, you know, it's an insurance issue if a monkey dies on your premises, right? Right? So it's it really doesn't matter, and that's why I use that monkey analogy quite a bit. J-Deep says nobody cares about what you know or how did you do unless you bring value. Sure, that's a good way of putting it. Yeah. All right, guys. So last call for introductions, last call for anything. Otherwise, I'm gonna put up my classroom view. So again, if you're on Instagram, you're welcome to switch over to YouTube. This is where like the Instagram view doesn't look as great. So you're welcome to join us over on YouTube, okay? The link should be pinned already in your Instagram chat. All right, but let's get started on writing an API. Like I said earlier, very underappreciated topic for data science. So right off the bat, I'm gonna start with a graphical representation. And this is basically what we're looking to do. Or rather, this is kind of the purpose of having an API layer. The purpose of an API layer is that it sits in between, essentially, you know, what we're gonna call the outside world. You know, all of the apps that utilize your code and your actual code. That's it. That's all we're looking to do. We're looking to build this layer that sits between the code that we wrote, right, the data science algorithm, and then all the other apps or all the other entities or people out there that could end up using your app or end up using the results of your algorithm. That's it. That's all you want to do. That's the entire purpose of writing an API layer. And because the definition is so loose like that, you should realize that writing an API is half art, half science. There are some steps you want to follow, but there's no hard and fast rules. You can do this in a variety of ways. And by the way, this graphic also comes out of my book, Your First Year in Data Science. So if you want to support me, I do sell that book on Amazon. You guys know me. I don't sell cheap courses or make any, fake promises. But if you do want to support me, this chart is the type of chart that you'll find in my book, Your First Year in Data Science. Okay, that's where I'm pulling this chart from. I made this. But that's essentially what we're going to do. So today we're going to walk through how we take our code and then how we connect it up to the API layer in order to be able to use it, in order to open it up for usage by other people. That's really that's really kind of like the overall goal here. We're going to focus on this center part and create the code that generates that. So I'm going to provide the most basic definition I can. And, I'm open that there's other definitions out there, but, I don't like drowning you guys in overly complicated tech terms, right? You guys know that. So the way I can describe it is it's a programming layer that serves as a gateway for your application. That's it. That's all we're doing. I call it a gateway because it can be accessed by any number of things. As you can see here, I'm giving examples. You could have your API layer. It could be feeding a traditional desktop app, a mobile app, some other server. Maybe you have an API that feeds another API. That's not uncommon, right? But that's the gateway part of it, right? That it can be open to any number of usage. And you'll notice that I specifically chose the word, it's a gateway for your application. I didn't say algorithm. I could have said algorithm. I could have said your data science project. But APIs are not exclusive to data science. They can be used for anything. Anything could be feeding the results of your API. There is no hard and fast rule that it has to be for your algorithm. It has to feed data. It has to feed this type of result. It can be literally anything you want. In many ways, when I'm saying gateway, I'm kind of implying that it's like a communication protocol more than anything else. It's really just a way for multiple types of applications to be able to exchange information back and forth. That's really all it is, right? What that information is, how that information came to be, doesn't really matter. It's more about the interchange. So what are the pros? With one layer of an API, that one gateway, you can support all kinds of apps, all kinds of platforms, and all kinds of languages too. That's an important part. Because remember how I said it's a transportation protocol or a gateway for that discussion, for that communication? Well, that communication can happen in any number of languages. You could have written an algorithm for data science in Python, but then the API layer enables it to be accessed by a C++ application, or it's able to be accessed by a web application using using one of the web frameworks, right? The API layer allows that type of communication that is agnostic to the language. You don't have to know the language that the person if we're here, if you and I are here and we're writing the Python side of it, we don't need to know or care what language people are using on this side to access the API. Or if you want to sound fancy, the fancy term is consume the API, right? That's the very polished way of saying that you're using an API. You're consuming an API. But we don't care. We don't care what language you're using. We don't care where they're using it. If somebody says, well, I'm gonna access your API via my mobile app, okay. We don't care if that's an Android, an iOS, if they're using Swift, if they're using something else, who cares? Like, it literally doesn't matter to us. That the API protocols, the way they communicate, it lets us just not really pay attention to what they're doing. It just lets us say, okay, here, we're going to open the API, and then you access it however you want, with what language you want, whenever you want, right? The documentation is fairly straightforward to produce. APIs usually have what we refer to as endpoints, right? An endpoint represents one of those gateway doors that somebody can use to access some function in your algorithm, in your application, right? So providing somebody with your API documentation is basically just coming up with those endpoints and saying, here, this is how you access those endpoints. And that's it. And there's a standard format for, right? What's the name of the endpoint? What's the input that's required by the endpoint? And then what's the result that your application is going to give me? So if you can tell me, where do I point my application? What information do you need from me? And then what information can I expect back from you? Then you have provided the documentation that anybody would need to access your data in any language, in any platform, whatever, right? With those 3 items, that's all you need. Something that you might hear associated with APIs also, very commonly, is something known as a call and response model. You might hear somebody say, yes, this API uses a call and response model. That's the most common scenario. And that, in effect, describes those same 3 items that I just told you about. Right? Where am I going? What do you need from me? That's the call, right? Me saying, I'm going to access this API and I'm going to send it this data. That's the call. And then us, as the application owners, the API owners, we process that data in some way. We come up with the result and we send out the result. That's the response. That response is what your API users will use in their application in whatever way they want to use it, right? But again, that's what simplifies the documentation, because you basically just need to always provide those 3 items. Here's my API endpoint. Here's the data you should be sending. And if you send me that data, here's the data I'll send back to you. So super easy documentation that makes it accessible to anybody who wants to use it, or that you authorize to use it. The third thing is the backend code can be anything you want it to be, right? Obviously, we're going to focus on data science. We're going to focus on Python, but it can be anything. As I said before, it could be just a traditional math formula if you wanted to. It could be a statistics approach. It could be anything you want it to be. It could be written in Visual Basic. It doesn't even have to be Python. It can be anything you want, right? So that's another thing that's a benefit of it. And then, as I said, the front end is also anything you want it to be. Finally, I put forward that it also simplifies the production efforts and time. This one's a little bit harder to explain, but if you ever end up working on a more advanced software development team, or a data science team, the first thing you're going to find people working on out of anything you do is the API layer. Because if I just told you that this back end can be anything you want, and this front end, these consumers of your API can be anything you want, then there is a massive, massive benefit to working on the API layer first. And that's where you can develop the API, you can write it, you can write the endpoints that you need. You can have those endpoints put out fake data, right? Because it's the backend code is not ready yet, but you have some fake data that's being sent out. And that enables you to now have 2 development teams working on parallel tracks. Because now you can have your back-end people, like your data science team. Your data science team can now start to work on filling in that dummy data, right? While your front-end people, your mobile developers, your Salesforce team, whatever, they can start working on their own consumption of the API, even though they're getting fake data at that point, right? But from a project management perspective, it's super important to have those types of parallel tracks going, where you can have your back end and your front end people working at the same time. You do that by coming up with an API layer, because if you can get both teams to agree on what the endpoint should look like, and you know what they are, the data, the type of data they should be returning, then you're capable of both teams working at the same time, right? I share this story in my book where I did some work for a crypto startup. This was a few years back, and I was basically the front end person. One of the co-founders was the back end person. And I was working in a god-awful language. I was working in WPF, which is one of the .NET tools. I was working in WPF. And by the way, this was the last .NET contract I ever did. I told myself I would never do .NET again. I was working in .NET, and that was in C#, I believe. And the co-founder, he was an expert in Node. He was an expert in Node.js. He was the back-end guy, I was the front-end guy. And we would sit there and we would basically build the API together. Now, both of us were advanced, so we were kind of just doing it verbally. We were like throwing ideas back and forth at each other. And I would say, okay, I would tell him, hey, I need an API endpoint to get me this, this, and this. And then he would quickly write it up on the API side. And he would, put some dummy data in there, and he'd be like, okay, go ahead and test it. And then I would test it from my end, and it's like, okay, yeah, got it. Okay, next I need this endpoint. And we just sat there for like a day, throwing endpoints back and forth at each other. And once we had that established, then I went off and did my work. He went off and did his work. I was working in C#. He was working in Node.js. It doesn't matter, right? As long as you have already agreed on what that middle API layer looks like, then both of you can sit there and work in your own languages, on your own different code bases, right? Because the front end code base was completely different than the back end code base. We could sit there and work. And once there was no more dummy data, we kind of come back together and do more testing, right? But for the purposes of getting a project off the ground, working on the API layer first, even though it seems counterintuitive, is a really good trick to be able to enable multiple teams to work at the same time. So that's another benefit of thinking about your applications from terms of an API. Because if you can get that layer stood up right from the beginning, you've really have put yourself in a good spot to be able to advance the project together from the back end and the front end. Okay? So Denelson says, good morning, Dennis. When it comes to injection or attempts in altering the API, how do we secure our API layer? Yeah, so Denelson, let me go to the next slide, because that is on my next slide. So I'm going to get to that, Denelson. So there are some cons to using APIs, right? One of them is that we're creating more code. We're literally coming up with additional code that sits on top of our algorithm. It's necessary code, but it's not like extraneous code. But you still got to maintain it, right? You still got to maintain it. And then you also need to track your code versioning. Do you have an accurate number of endpoints? Have you deprecated any endpoints? Do those endpoints call the latest version of your algorithm? Do they go to the latest version of your code? Maybe they do, maybe they don't. Who knows? Right? So those are the types of things that we need to think about in terms of, am I accurately working, or have I invested the appropriate time to take care of the API, right? Because the API now kind of becomes like this, I don't want to say like a liability, but it becomes something where it could become a point of failure. That's really the better term I'm looking for, right? So to Dennelson's point, an API is also a security risk, right? Because this gateway kind of sits out there available to anyone in theory. Excuse me, in theory, right? But this is where you have to involve some cybersecurity practices, right? This is maybe where you would have some sort of a key exchange to make sure that only certain, only authorized parties are accessing your API. Maybe you also limit the API access by like a membership of some kind, right? On top of that, there can be, as Dennelson says, injection risks, right? Injection attacks are always a concern when you're taking information from the public. So maybe there's additional code that you need to implement to check for injection attacks. That can be solved in a coding way, right? In addition to the cybersecurity side of it, you can have your own additional code checks for things like injection attacks, right? So that is something to be concerned about. So Dennelson, thank you for that question. It really does address, or start to talk about some of those cons that you need to be aware of with APIs. And then finally, there's also performance monitoring that kind of comes into it, right? How do you optimize an API? There's really not a lot of hard and fast rules to that. How many servers do you need to serve up your API? Well, that depends on how many people are using it. You may not always have an accurate count, especially if you have an API that's open to the public, right? Like, if you come across an API right now that gives information or data to the public, it might be overused, right? Overtaxed. It might be overused on a seasonal basis. How do you track that? How do you fix that? That's not always clear with APIs. Most of the time, that's not even going to be your decision. It's also going to be, you would have to involve some sort of, ML ops people or IT people, right? Or traditional DevOps people, right? Doesn't have to be ML ops for the API layer. It could be just DevOps people. But how do you know that? How do you know that you need three servers instead of 2 servers to serve up your API? You kind of don't, right? I mean, you can get an idea of the performance hits and the traffic, but the accuracy is kind of wanky, right? And then also from the performance side, what happens if people start complaining, oh, the app is too slow, the app is too slow? Okay. Well, is that your HTML page that's too slow? Is that your API layer that's too slow? Is that your database that's too slow? You don't know, right? You've by using an API layer, you've now added an additional component that kind of adds to that doubt of the things you'd have to test and look at and say, well, maybe our API layer is the problem. Maybe the database is just fine. Maybe it's the API layer that's the problem, right? So those are the types of things that are kind of negatives to using an API. But I think that the positives still outweigh the negatives because it really opens up your work to be used by a lot of different things, a lot of different people, a lot of different applications that can benefit from algorithms, right? Because at the end of the day, we want to show some positive impact from our work, right? So if we're able to say, hey, we wrote this algorithm, we have 3 different endpoints, and we can show that those endpoints were accessed 500 times, and they gave this number of accurate results. That's a good way to measure impact, right? So I think that the the potential downsides of APIs are definitely outweighed by the benefits. Okay? All right, so I covered a lot of ground there. Let me know if you have questions, but otherwise, I'm ready to start looking at some code. Well, I'm ready to start asking ChatGPT for some code. So, first thing I want to do, guys, is I want to very briefly go to the terminal window. And let me know if you need me to make this bigger. I think that's pretty big. Let me know if that's okay on the screen, guys. But building on our previous series, I want to make sure that I go over Conda in summary one more time, because I think that there were still some challenges around Conda from the last time we spoke about it. Usually, I would have already had the Conda environment created and activated, but I want to go ahead and show you those steps again, just because, just to make sure everybody, kind of remembers them from when we did them. I think 2 weeks ago. I think it was 2 weeks ago. Yeah. So remember, well, actually, no, this is participation time. Can somebody tell me in the chat why we want to use Conda? Why are we even talking about Conda? Why do we even care about environments? Let me know in the chat. Some of you guys might remember this from 2 weeks ago. Some of you guys might already know this on your own. But let's put that in the chat. Why do we even care about environments? Let me know in the chat, guys. Audience participation time. Why do we even care? Why do we even need to have a discussion on Conda? Or if you want to take an advanced view, give me a definition for Conda and environments. What do you guys think? I'll give you guys a minute here to talk, to think about it. Excuse me. Give you guys another minute here. Why do we even care? Excuse me. Why do we even care about Conda? What is it? What do you guys think? So Rex says, isolated environments are important to avoid software conflicts. Rex, I like the way you put that. I think that's it. That's it. I think Rex hit it right from the beginning. The whole point of us creating environments is to isolate ourselves or isolate our work so that we don't have software conflicts. Anise says it's to organize different projects. If we have a diverse workflow, it's easier to manage dependencies for each specific project. Yeah. Yeah, I like that Anise mentioned dependencies, right? Because each project has its own dependencies. Some projects you're going to need NumPy, others you're not going to need NumPy. Some projects you're going to need Python 3.11, other projects you're going to use 3.13, right? So the whole point of environments is to be able to create those silos for yourself so that you can work in any version you want, any combination of versions that you want. And you won't mess up your base system, and you'll won't mess up any of your other projects. You'll be able to work in that environment with no conflicts whatsoever. So thanks to Rex and Anise for those great definitions. I think they were very accurate. So I already have Conda installed on my machine. There's many ways for you to do that. But here's the key line that we need. I'm going to go up to the key line. I'm pulling from my history file, because I was doing some work recently for another one, another environment. So here, this is the key of what we're gonna need. And let me add my item here, and then we'll talk about this. So The first word, Conda, because we're using Conda as our package manager. We're asking it to create a new environment. We're using the -n to say that we want to name the environment. We're naming it API build. We're choosing that name. And then Conda, while Conda is generally thought of as a Python tool, it can be used for Python and R. And I think it supports other languages too, if I remember right. But we can choose and we can say, and by the way, I want you to be put in Python, and I want to use a specific version of Python. And in this case, I want to go ahead and use 3.13. That's the latest stable release of Python. So with this command is how we are saying, hey, I don't want to mess up my system. I want to create a dedicated environment. So Conda, create me an environment that uses Python 3.13 and go ahead and call it API build. That's what this statement here says. So let's go ahead and run that. And now it's going to go out to the Conda repositories. Rex says increase the font. Okay, give me just a sec. Okay, let me know if that's better, Rex. So what has happened now is Conda has gone out and it has to what's known as the repos, the repositories, and figured out the different items we need. So you can see here, it's going to go ahead and install Python. It's going to install pip, which is another way to install packages and whatnot. And here you can see it's going to, it already knows, it detected that we're on OS X, and it's going to go ahead and do Python 3.13.1. So everything looks good there. That's a fairly standard install of Python. So we go ahead and click on yes. And now it's going out, downloading them and installing them for us. So we're going to give this just a minute here. And now it's done. What this here is telling us, it's telling us, hey, I've created your environment, but I haven't started it. And we start it by this command, conda activate, and then the name of the environment that you want to activate, which in our case is API build, because that's the name we designated. So now, and very quickly, I want to show something. So if I go Python version here, you can see that I actually don't even have Python installed in my local directory or in my local install of my OS X. But when I go ahead and I activate API build, now we are activated, and you can tell because this has been added to our prompt. This is telling us that not only do I have a prompt, but that prompt is working within the API build environment. So now when I go ahead and I go to Python and I check the version, it's telling me that I have Python 3.13.1, which is what we had designated, right? That's what it told us it was going to install, right? It's up here also. So you can see we went from one environment, my base environment, of having no Python to working in an environment that does have Python. And we did that just by switching from my base to an environment. So now that should illustrate to you how you can have those separated items so that some work you're doing over here is not going to affect other work you're doing over here because they may have completely different dependencies. So super valuable as you get working more and more into different projects, different explorations. Okay? All right. So that's Conda. That's Conda, but has nothing to do with APIs, right? That's just Python development. So this is where we need to call in our employee, ChatGPT, right? Because we're doing an AI first attitude towards everything, right? Now, I know how I've written APIs in the past. So I'm bringing some domain knowledge here, but an AI first attitude is to ask ChatGPT, hey, What do you know about API layers? Can you help me write an API layer? What frameworks do you know for that? Okay, so let's do that. And again, let me know if you need me to adjust the font here. And we don't want any complex code, right? We already said that we're going to have to maintain this, right? So why create complex code? So we're going to include that as part of our prompts. And then we're just going to basically ask, what frameworks, what Python frameworks does ChatGPT know for that? So if you've been to some of my other classes, we've done something similar, right? We've asked ChatGPT in the past, hey, I want to do some clustering algorithms. What do you know about clustering algorithms? Or, hey, I want to work on nearest neighbors. What libraries do you know for nearest neighbors? Right? We can kind of play dumb, right? And say, hey, what do you know? What are you best at coding at? Right? All right. So how many did it give us? 4 different recommendations, right? It says Flask, lightweight, great flexibility, and minimal code. Hey, that sounds good, right? Fast API, modern, fast, high-performance framework. Makes it easy to write and validate data. Okay. And then we have Django. Django, full-fledged web framework. REST framework extends to build APIs. Best suited for projects require a full web application alongside the API. Okay. Bottle is a micro framework like Flask, designed for simplicity, suitable for very small applications. Okay, so that maybe if you're still doing exploratory phases, that sounds like maybe you want to explore that. And then the final recommendation, if you want simple and lightweight, Flask or Fast API would be the choice. So yeah. So real quick in the chat, let me know if anybody has a preference for these. I have a preference, but I'm trying to kind of get a feel for you guys, if, what experience you guys have. Or we have some people who have some software development experience in the chat today. But yeah, let me know what you guys think. Flask, Fast API, Django, or Bottle. Rex says, first time hearing Bottle. Okay, Rex. Bottle's been around for a while. It's not my first time hearing it. I think I've used it in 1 or 2 projects. But yeah, Bottle's been around for a while. But you know what? That's the beauty of taking this approach, right? Because you don't know what you don't know, right, Rex? So if we would have never asked ChatGPT, hey, what frameworks do you know? You would have never known this, right? Personally, for me, Rex, I've never heard of Fast API. I've never heard of that. I know that there's tools like it. I think I know some of their competitors, but I've never heard of Fast API, right? I would have never known that, right? But let me know, guys, if you have a preference for one of these. And if you don't have API experience, that's totally okay too. Feel free to put that in the chat, right? But, if you have a preference, let me know. Okay, so Siva says, can you show us all the... Siva, I'm sorry, I think your message got cut off there. Let me know what you mean there, Siva. But, okay, over on Instagram, is it Shashank? Shashank says, just learning Django, so I go with Django. Okay. Rex says, I've had a very limited experience with Fast API, Flask, and Django, and by limited, I mean very superficial knowledge. All right. Anybody else? Last call, and then I'll give my my decision here. If you guys are over on Instagram, thanks so much for joining us there. You're welcome to stay there, or you're welcome to join us on YouTube. Anise says, I don't have API experience. Okay, cool. Thank you, Anise. Appreciate you stepping up. You know, it's not always easy for us to admit our shortcomings, right? So it's good. It's good for people to, you know, be able to say, hey, look, you know, I'm just not knowledgeable. Siva says, can you show all the framework abilities? I don't think we have that much time, Siva. It's not so much about learning each framework. It's my intent today is not to teach every framework. It's to teach APIs. So what I really want to do is I want to make a, you know, a kind of a fast decision on this, and then just go ahead and show how we complete an API in one of the frameworks. And then you guys can extend that forward to looking at all the other frameworks, right? You know, like our friend Shashank over on Instagram is saying that they know Django, right? They're learning Django. Michael is sharing that they're familiar with Django and Fast API. So really, Siva, that's the intent. The intent is to teach you about APIs, and then you guys can carry that forward in your own individual learning, right? All right, but really good feedback, guys. Thanks so much for that. So Fast API, I am new to. I do not know Fast API. I have worked with Bottle once or twice. So that leaves us with both Flask and Django. Personally, I'm a huge fan of Flask. And that's how I wanted to start. I was gonna say, oh yeah, I'm gonna ask ChatGPT to start writing some Flask code. But again, we're taking an AI first attitude. So the whole point is to go ahead and have ChatGPT tell us what it can do. But you can always put in your own domain knowledge, right? For me, Django is nice, but it's very heavy duty. It's very heavy duty, and it's harder to work with the templates. Because remember, you can also serve up HTML with these frameworks. Django is nice, but to me, the templates are a little bit janky. Whereas the templates for Flask are very easy to work with. A lot of people will tell you that there are a lot of similarities between Django and Flask, but Flask is a little bit more lightweight. It's like a slimmed down version of Django, right? So what I'd like to do is I'd like to proceed with Flask, because I think that the code will be a little bit more straightforward for ChatGPT to write, and it'll be a little bit more straightforward for all of us to understand. And that's really my intent today. My intent is to provide us all with code that we can understand and that we can work with in a very, very quick way, right? So that's what I want to do, guys. So we're going to proceed with Flask. We're going to talk about API development in a generic way, right? We're not going to be Flask specific. Only the code will be Flask specific. But you should be able to take this forward and say, okay, let me take what I learned from Dennis today, and I'm going to go do it in Django. I'm going to go do it in Fast API later. Right? So let's do that. We're going to ask ChatGPT to continue working in Flask. Michael says, true, Django is complex. Yeah, Michael, and you know what? To me, it's like unnecessarily complex. Like, it just feels like they're trying too hard, if that's possible. When you compare it to like the way you could be doing templates in Flask, it's like, well, gee, why aren't the Django templates this straightforward, right? So yeah, guys, if you have any experience with Django, you'll know what we're talking about. If you don't, that's okay. You know, you're welcome to do your own exploration. I don't want to bias anyone. I don't want to discourage anyone. But to me, Flask is just 10 times easier to learn or to understand than Django. But yeah, thanks for that feedback, Michael. I completely agree. So we're going to choose Flask. All right. So yeah, this looks great. Again, I'm using a little bit of my own like domain knowledge because I've used Flask. So I'm able to quickly double check the code that they're giving us here. So to me, this looks great. Let me bring it over to Visual Studio Code. Let's go. All this. I think I need to make that bigger. All right, let me know if that's big enough, guys. Let me go ahead and, how do I, it's this, yeah, there we go. Okay, so lots to look at here. But this is the first version of the code that it gave us, and it looks pretty good to me. Couple things I want to point out. We're going to start at the bottom. So remember what I always tell you guys. I want you guys to focus on writing Python programs, not scripts. Programs, not scripts. Lalman, how are you? Good to see you, my friend. Lalman says, it's big enough, Dennis. Okay, cool. Thank you, Lalman. Appreciate that. I know it's late for you in Nepal, so thanks so much for being with us. Okay. Programs, not scripts. One of the defining measures of a program is that it has what's known as an entry point. And that's a programming term, not just a Python term. Most languages support entry points. So if you'll notice, in my initial call, I asked it to give us an entry point. An entry point as a server. Because remember how I told you that an API layer is open to the world, it's a gateway? Well, the way you create that gateway is by running it as a web server. That's kind of like one of the underlying tools that's used by APIs. That at the end of the day, it's still kind of using that HTTP TCP/IP protocol for that communication back and forth, right? I'm not trying to get too crazy here, but you know, if you've never heard of the TCP/IP protocol, it's basically what makes the internet possible, right? TCP is like a communication protocol that enables traffic to go across networks, essentially. So we're kind of like piggybacking on that by saying, hey, my API runs as its own web server. And so the reason why it can be consumed by so many different applications, so many different types of data, it doesn't matter, is because at the end of the day, you're kind of using that underlying TCP/IP protocol, right? So again, not trying to get too IT on you guys, right? But that's why we're using a web server. So that's the entry point. The entry point is saying, hey, I want you to run this application and I want you to run it on this host address. This right here is an IP address. And then we're specifically using port 5000. So we're going to go ahead and say, run this application on this port. And whenever a request comes into this port, have my code, this application code run something. Okay? You've heard me refer to endpoints. And that's what these are. That's what these app roots are. An app root is an endpoint, at least in Flask, right? But when you hear of an endpoint, you should be thinking of some sort of root. And this is basically saying when somebody comes to this address, this port number, and to this endpoint, or if you think about it, traditional development, to this page, the hello page, I want you to return this. Here's the function I want you to write, and I want you to return this. And that's it. Remember how we talked about the call and response? The call is to hello, and the response is, hello, welcome to the Flask API. This is the call and response model in a single endpoint. So right here is a pretty good representation of everything that needs to happen for an API. That's all you really need. I'm really happy that ChatGPT posted another one. And this time it said, I'm going to give you a second endpoint. It's going to be called sum. And this is what I want you to run when somebody calls sum. It gets an argument. It gets two different arguments of A and B, makes them into floats, and then adds them and gives you the result. So here we have a little bit of a complication, right? Because here it's going to request the arguments of A and B. So in other words, it's expecting us to provide those arguments. And I'm going to show you how we do that. But it's two endpoints that are distinctly different. In the first one, it's basically like your hello world type of statement, right? There's no arguments to collect. Here in the sum endpoint, there's going to be two arguments to collect, A and B. And it's going to do something, process A and B. In this case, it's just a sum, right? No big deal. And return the result. That's the response it gives. Okay? So, how do we access this? We need to start this, right? We need to start this terminal. Excuse me, we need to start this web server. Because remember, you don't really use the API as a library like you would in other situations. You run it as a web server and then you access it via a web call, right? So let's do that. So if we go to our terminal, we go here, we can see that we have our file API layer.py. But we also know that we haven't done our install, right? We haven't installed Flask, right? Let me change this here to reflect the right runtime. So that's the runtime. So first thing we need to do is just some housekeeping. Pip install Flask. So again, if you're not familiar with environments, you're not familiar with installs, this is a very common way to install libraries. Pip is a common package manager program. We're asking it to do an install, and we're asking it to install Flask. So that's the first thing we need to do. And it's already done. So if we go back to our code, we can see that the warning is gone. Yep, so now the warning has disappeared because it's detected that we properly installed Flask. So now we should be ready to start this. I'm a little unclear on the API on this IP address. I think we should modify that IP address. But let's keep going. My gut tells me we need to modify that, but let's keep going. So what was it called again? API layer. Yep. So Python API underscore layer. Address already in use, port 5000 is in use by another program. Okay. Okay, no problem. So that's going to be a common thing, guys. Let's go back to look at our code. Remember that I said we're using both an IP and a port address. That port has to be unique to our application and it can't be used. So we got an error because port 5000 on Mac is already used by AirPlay, it sounds, right? I didn't know that. That's okay. This port can be anything we want it to be. So let's use port 5077. I'm making that up. I'm assuming it's unused. But unless that port is completely empty, then Python and Flask can't latch onto it. It doesn't matter what we call it at the end of the day. So let's just go with 5077. So let's do that. Okay. So now it's running. Okay, so this is what I had forgotten. So what's nice about this is that it tells us the IP address that it's using. It literally says, I'm ready to go. The way you can interpret this message that's on here is you can say the application is telling you, I'm ready to go, and I'm listening on these two addresses. So it's giving me my local host address, like my local home address, and then it's also giving me my local IP address. And you'll notice the 5077 port that we chose. So now this is telling us, anytime you want to talk to me at this address. So if we take that address and we go to a window, this is a, just a standard browser, right? Because it's a web server, right? So we have to access it this way. This is what we're looking at. Now it's telling me that the URL was not found, but I want to test something here real quick. Yeah, cool. You'll notice that it first told us, when I went here, it told us that it was not found, that address was not found. Can anyone tell me why that is? Can anyone tell me why it's telling me that there's nothing here, but yet when I went to hello, it gave me this, hello, welcome to the Flask API? Can somebody tell me why that is? Anybody want to take a guess? Let me go back and bring up the code. Why did it give me an error when I went to the IP address, but when it went to hello? Okay, yeah, Yassine, thanks so much. Rex says, voila. Yeah, it is kind of magical, right, Rex? So Yassine hit it right on the bat. There's no endpoint for that address. That's all right. Denelson says, because we didn't have the endpoint for that case, was not pointing to the right address. So yeah, Denelson, Yassine, you guys are on the right track, right? Remember that we are basically creating a web server, which is great, but that means that we have to manage it granularly. So if there is no endpoint, then there's nothing to show, right? There's no case to redirect the blank address to the hello route. That's right, Donaldson, that's right. So can we do that? Yeah, we can do that. What we can do is we can do this. We can take this off and say, now, anytime you come to the page in the root, I want you to do this. And we're going to say that they can come to the root. We're going to distinguish between coming to the root of the server versus it telling us hello from the Flask API. So now we have a second endpoint that we created just for the root page, right? So let me go back and try that. What should I expect now? Can somebody tell me what I should expect when I go here? What should I get now? Anybody know? Before I press enter, what should I get? Anybody tell me that? What do you guys think I'm going to get here? We created the endpoint, right? Lawman says, welcome to the root. Okay. Anybody else? What am I going to get now? The message, Yassine says the message that we wrote, Denelson agrees with Lawman. So that's actually not correct, guys. Actually not correct. We come back to the same error. Can anybody tell me why? This is really important when it comes to APIs. Anybody tell me why we came back to the same error? Oh yes, the slash. Not quite, Yassine. Not quite. See, that just takes us to hello, right? But even if we add the slash, we still get the error, Yassine. Anybody figure out why? There's a pretty good reason why we're getting the same error. Anise says the code was not run again. Okay, Anise, yeah. You had to find slashes. Yeah, that's true, Lawman, but we still got the error. So Anise is on the right track. The answer is here. In the terminal. Remember how I told you that we're not running the code, we're running a web server. We're not actually running the code, we're running a web server that takes in that code. But if you haven't restarted your web server, that new code doesn't exist to the web server. That's why we got that error. So one of the little bit of janky things of working with an API like this is that you have to make sure that you're restarting your server at appropriate times. Because as you change the Python code, even though you're saving it, that's not the web server. The web server lives apart from that, right? So here, we're actually going to be pressing Control-C quite a bit. And then we're going to be restarting the server. Same screen we got before, right? It's still saying, I'm ready for your requests. But this time it's using the refreshed version of our code, right? It's now reusing this version. So now if we go back and do this, now we get the welcome to the root of the server, which we know we should expect. So I want to make sure you got, I put an emphasis on this because this can kind of trip you up in your development where you'll drive yourself crazy and it's like, oh, it's because I didn't restart the server, right? Because you're not serving up the code, guys. You're serving up the server that serves up the code. It's like an additional layer. It's even though we're introducing the API layer, this is like another layer on top of your API layer. Do you guys see how here in the terminal, it says debug mode is off? So we can help ourselves. We can help ourselves by turning debug mode on. What debug mode does is it goes ahead and anytime you save, you hit Control S in like Visual Studio Code, it'll restart the server for you. So we can help ourselves by doing that. By saying, hey, by the way, anytime I press save, go ahead and restart the server. But by default, debug mode is off. So I think we can control that in code. I believe that the control for that is down here. I just can't remember what it is exactly. So let's go ask our employee, right? We don't have to know the answer. Only our employee has to know the answer. So let's go ahead and encourage ChatGPT here. So debug parameter is true. Yeah, okay, that's what I thought it'd be. So it's saying that if we add this after our port number, it'll restart the server for us anytime that we click on save. So this is one of those like little tricks that you learn after working with Flask for a while or, web servers for a while. But keep in mind that you're not serving up the code, you're serving up the web server that serves up the code. So you got to make sure that you're constantly restarting it, okay? So we're going to save this. We're going to come back here. We are going to restart this, right? Because even to start debug mode, you got to restart your server. So now you can see that debug mode is on, right? So now let's do some more changes or some more work. So now if I come in here, I'm at my server and I go ahead and type in hello. It serves up the page, right? Welcome to the Flask API. Now I want to say, I want to add a new endpoint that says goodbye, right? So we have a hello. Now let's do a bye. Here we do bye. And we're going to change the message just to make sure that we're getting something else. See you next time. I hit Control S to save. I'm going to go back here to my server. I'm going to go ahead and click, change hello to bye. Why did that refuse to connect? Did I make a mistake? Oh, because of this, right. So my server is probably crashed out by now. Yep. Okay, guys. So I was rushing a little bit too much there. So I made a mistake. I crashed out the server because I gave the same name to two different methods. Because remember, these are still methods that are being run. So you still have to follow, the conventional rules. And conventionally, you can't have two methods with the same name. So I made a mistake there by naming them like that. So it crashed out the server. You'll notice that I'm back at the prompt because the server is no longer running. So I'm going to go ahead and restart the server. And now when I click on buy, or when I ask for buy, it'll give me the right message. But what I was really trying to get across to you before I made that mistake was that you'll notice that here is the key line. This is what debugging got us. Debugging said, hey, I detected a change in that file. So I'm going to go ahead and reload myself as the server. And that's what we're going to want. Because we're going to be making constant changes to the API layer, especially in early development, right? I mean, eventually it'll stable out. But in early development, we're going to be doing a lot of changes. So you want to have that debug mode on so that you don't have to constantly restart the server, right? So that's really what I had intended to show you guys. I made a mistake by reusing the names, but by having the debug mode on, it lets us kind of work with a little bit more peace of mind that our code will be more accurately reflected because the server is consistently being restarted to serve up the latest version of the API code. All right, I hope that makes sense. If not, let me know in the chat, okay? Denelson says, I don't remember much about Express.js, but it does eliminate the need to rerun the code. Denelson, I don't know. I've only used Express.js on a couple of occasions. I'm really not a Node guy. So I don't know, Denelson. I honestly don't know the answer to that. Denelson says, I think it's debug equals true. Yeah, I thought so too, Denelson. But we don't have to know anymore. Our employee needs to know this, right? So Lallman says, interesting. Yeah, Lallman, I hope you are finding this interesting because I think this is a whole other dimension to data science development, right? Or really just to Python development. Because again, you could be a software engineer doing this, right? Okay, so Denelson is asking a good question. Denelson is asking a great segue question. Can our backend APIs call other backend APIs we create? For example, can our hello call the sum API? Yes, it can. Yes, it can. But Denelson, at this point, I'm going to encourage all of us to not think about it as APIs, but think about it as additional libraries, right? Because it's really libraries that we're interested in. We should really only have one API that's open to the world. But then where that API goes on the back end is kind of like where the magic starts to happen, okay? So let me come back to that, Denelson. Let me come back to that because you're asking a great question. But before we go in too deep into that, I want to look at something else. We have another endpoint. We have the sum endpoint, right? We haven't done anything with that yet. Let's go there. I'm going to go ahead and change here. I'm going to change by to sum. Tell me in the chat, what am I going to get when I hit enter? What do you guys expect me to get when I hit enter? What's going to happen when I call the sum endpoint? I'm going to type it just like this, and I'm going to hit enter. What should I expect? What do you guys think? Give you guys a minute here to think about that. If I go to sum, what should I expect to see? Let me know. What do you guys think? If I go to sum, what's going to happen? Ah, Denelson, very good. Denelson says error due to not having A and B arguments. That's exactly right. That's exactly right. It's gonna be zeros, right, Denelson? Because we do have a default, right? There is a default value of 0. But Denelson is right. It's gonna give us a bad reply because the whole point of this type of endpoint is that we can pass data, right? Remember how I said about this call response model? So we've seen that, right? We went to the hello, we called the hello endpoint, and we got the response. We went to the bye endpoint, got the response. But sometimes we need to send information. We need to send arguments as what it's referred to in Flask. So here, as Denelson correctly points out, it's expecting A and B. If A and B are not there, it gives a default value of zeros and it still processes, right? And if you'll notice, it puts it into JSON and then it gives, this is the end result, right? But Denelson is right. We didn't pass anything. So let's start passing things. Look at that. What do you guys, oh, actually, I need that bigger, don't I? Now, what do you guys think? Do you guys see what I did? You guys see it? A now became 10. B became 15, and the sum, the answer, is 25. Now, obviously, this is a simple math operation, but it processed our data, right? It processed our inputs. And it did it by adding it to what's known as the query string. If you guys don't know that, this is referred to as the query string. We just put a question mark and then A equals ampersand, B equals whatever, and it gave us an answer. Because those are our inputs, right? Everybody see that? Let's go back to the code here, right? The code is set up for that, right? Request.args.get is what pulls in A and B and then here, this line here is the algorithm, right? Any math formula technically is an algorithm, right? You guys with me on that? Let me know in the chat if you guys see that or not. But I think I think that I like the way that ChatGPT set this up for us to give us like another dimension on the endpoints. Because not all endpoints require inputs, but some do, right? By and large, you are going to need endpoints that require some sort of information from the requester, from the consumer of the endpoint, right? Okay, Denelson says, yes, I'm with you. Okay, cool. So, so far, we're dealing with a fairly straightforward set of endpoints, right? You know, some of these we can remove. You know, we had the hello and the bye and stuff like that, right? But as you work on more complex projects and more complex APIs, you know, certainly like the corporate level projects, you're going to need multiple endpoints. You're going to need like, you know, I've worked on projects where you need like a couple dozen endpoints, you know, maybe more, right? So you have an endpoint, and then here we had a try and accept. We'd have to do another endpoint for a try and accept, so on and so on. Doesn't that sound a little messy though? Doesn't that sound like you'd have to, like, it'd be a lot of code really quickly, right? And you'd have algorithms within the code. Like if you think about some of the algorithms that you've maybe written in the past, you're going to have to include your neural network code or whatever right in here. That seems a little messy, right? So this is where we get into something else. This is where object-oriented programming really comes into place. This is where you should also start seeing the limitations of using notebooks. Because what we really want to do is we want to have our API layer to be standalone. And then the API layer itself should also be a consumer of other libraries that we wrote, other programs that we wrote. We shouldn't have this type of algorithm, right? This sum. This shouldn't be inline code. By the way, if you guys aren't familiar with that, that's what this is known as. This is known as inline code. Shouldn't we be making this a call out to another library? We should, right? Because that's how you create, you know, more organized, more importantly, more maintainable code. It's kind of messy to have inline code. On top of that, you've also created a single point of failure in this API layer file. What happens if this file goes missing or goes corrupted or whatever? There goes your entire code base, right? So I don't want to see my team turn this in. This is where you should be making a call out to other projects, other files, other classes is really what I'm meaning to say. Other classes. Because then you can have your isolated API layer calling your individual classes for the different tasks that it needs. And again, this is kind of where you get into like that professional polished code. When you start thinking in these terms of objects and libraries, like that's where you're a professional, right? Like this isn't no student project now, right? This is like a professional approach to it, right? So I have ideas of how to do it. I think it's fairly straightforward to do it. But again, we have our employee, right? So let's go back. Let's go back to ChatGPT. And we can, what we need is we need to take the calculate sum and we need to make its own object. And then we need to consume that object within our API layer. That's the professional approach. Remember how I talked to you guys about how we're going to be the architects in the future, right? In the future, we're not going to be coders. We're going to be architects of data science projects. This is what I mean. This is us thinking about it from an architecture perspective, right? The architect in us should say, well, wait a minute. This sum method really needs to be its own class. So I'm going to break that out into its own class, and then I'm going to consume it back into this API. So let's do that. I think this is a reasonable prompt. This works great, but I want to see the calculate sum method in its own individual class. Please write a brand new class in a brand new file that contains calculate sum, and then call that class from the API code. And we're going to say that new class from the API code. I'm trying to be very specific here in the way that I'm prompting. You'll notice that I said brand new class in a brand new file, because some people some design patterns would put the class within this file. But to me, that's a little bit messy. You really kind of want to break that out so that it can be worked on individually, independently from any other help or any other kind of code conflicts, right? Let's go ahead and do that. Let's see what it gives us. Okay, so it's going to have the file contains calculator class with the calculate sum method. Okay. You can see here that it also now has an import from calculator, import calculator, which makes sense. We need to name it calculator.py. And then down here, you can see that we've greatly simplified our code because now we're using the calculator class to perform the sum. We still need this code to get their arguments, right, the A and B, but now we're going to go ahead and just say we don't need to do all those results in here. We just need to go ahead and call the calculate sum method from that class. So I think I'm on board with this. So let's go ahead and do this. So we need to take this code and we need to put it in calculator.py. Let's go ahead and do that. We're going to paste that. So this class is fairly straightforward, right? We're declaring the class. It only contains a single method. It takes in two float values, and it goes ahead and returns the sum, right? The A plus B. It tells you what the original inputs were and then what the result is, and it returns it in a dictionary. I'm pretty sure that it's returning it in a dictionary because that's what you need to convert it to the JSON format that it eventually uses for the output on the web server side, on the API side, right? So that's what we're going to do here. And so that's what we need to do when we modify this, right? So now let's go ahead and go back to the new server, copy this code, and we're going to completely replace this. So the two changes are here, right? From calculator, import the calculator class. And then down here, it's this. Calculator.calculate sum of A and B. And A and B are the two values that we posted here, right? So I'm on board with the way that looks. If we go to our terminal, we should have seen a restart. Yep, it just restarted because it just detected that we made a change to our API layer. So now if we go back to our server, if I run this again, what is the expected result, guys? If I hit refresh here or, enter again to bring this up, what are you guys expecting to see here? Let me know in the chat. What do you guys think is our expected result of refreshing this page right now? Give you guys a couple seconds to think about that. What can I expect when I run this page again? Yassine says the same. Yeah, that's exactly right. That's exactly right. We are going to be getting the exact same result. Siva says just some, I believe. Okay. But yeah, when we refresh this, we got the exact same result as before. Denelson says we haven't changed our code in the API file, so I don't think it would change. Well, we have though, Denelson, right? We are getting some in a completely different way now, right? We have a whole new import and we have a whole new way of getting that sum. But Yassine is right that there is no change, because if we go back to our chart, all the changes that we've made have been on this side, right? But to the outside world, they are still accessing the same endpoints. And we didn't change the nature of the operations, right? It's still a sum, it's still a plus, we're still adding. But from this perspective, the outside world perspective, there's been no change. We made the code a little better, we made it a little bit more elegant, but there's no change. There's no change to them. And again, they kind of don't care. They don't care how we're getting the sum. They just know what endpoint to call and that they need to send the A and the B value, and that's it. But to them, it's completely agnostic. We could have said, hey, from now on, when you do that summation, don't do it in Python, do it in some other language, and then send the result back. And to them, it would still be the same. They literally do not care. All our changes were done on this side. The endpoint name stayed the same, the requirements stayed the same, but they literally don't care. Speaking of that, so we have this new class, calculator.py, right? Does it matter how we came up with the answer? It doesn't, right? This is where I'm telling you guys. We could be doing it in any language. We could be doing it with an algorithm. It could be a neural network. It could be regression. It could be a fast algorithm. It could be a slow algorithm. It could be good-looking code, bad-looking code. Doesn't matter. It could be the room full of monkeys, right? Calculator.py could be just asking a group of monkeys for their answer and returning it. It literally doesn't matter. So again, right now I'm kind of giving you guys the meta view, like the pattern, but this could be an algorithm. This could be the stock forecasting algorithm that we were working on 3 weeks ago, 2 weeks ago. You could be calling that here. That could be your calculator class. Right? There's basically nothing stopping you from doing that. How about this? Is this valid? Anise, my friend, you're getting it. Anise is getting it, guys. So this highlights why OOP shines through. The code is cleaner with importing a class containing the algorithm. Yeah. Yeah, absolutely, Anise. Another way that you're 100% right. But another way it should also shine through for you guys is think about it from a project management perspective. Think about the division of work. Now you could have your data scientist team working on calculator.py while your MLOps team, your DevOps team works on API layer.py, right? So Denelson earlier brought up the concern about security. Well, you can have your IT people working on API layer while your data scientists are still filling out the calculator side, the algorithm side, right? While you're still training the monkeys to use the iPads, right? Think about that too from a division of labor. Super important to keep your project on track, right? In that case, we wouldn't call any of the training or fetch data. We would call a function that loads a trained model and returns it. That's exactly right, Denelson. 100% right. Yeah, you're not calling the training here. You're calling the prediction side. And then API, just give me the bottom line prediction, right? Like literally just send back the one single number prediction. That's the return that you're sending back to the API layer. You can even break it down further, right? Or think about what I just added here. I just added a brand new method. So maybe Denelson, you're still refining that output, or you want to have multiple outputs. Well, you can just have you just add another method. And now you can talk to your API guys and say, hey, by the way, I added this new method. Please create a new endpoint for that. And then that's accessible, right? Because we added calculate subtraction here, right? But it's not open to the outside world. It's not in the gateway until we do it here, right? So now we're going to go here. We're going to copy this. We're going to make sure we avoid the mistake from earlier. It's not going to be calculate sum. It's calculate subtraction. And then here, the endpoint is going to be called subtract. And that's it. We don't need to change anything else, right? We don't need to change anything else because it's still the same. A and B. Actually, no, we do need to change this. We need to change the call here. We're not calling calculate sum, we're calling calculate subtraction. So we do need to change that. But now we're calling, we just enabled, we went to our class, our calculator class, we added a brand new method, and we know that method works because we can test that in other programs, other projects, other unit tests or whatever, right? Because that class can be independently used in other things. We enabled the endpoint, which opens it up to the outside world, right? Makes it part of our gateway. And now this becomes a new endpoint for people to use. Now we have a subtract class, or endpoint, excuse me, that uses A and B and gives you the subtraction of those. Because here we're calling our new method in our class. But again, to the outside world, what that class is, what it's called, how we do it, doesn't matter. The only thing they know is that this new endpoint of subtract is now available. So if we go here and instead of sum, we call subtract. There it is. 10 minus 15 is -5. How we got that answer, what language, whatever, who cares? The consumer does not care. Just tell me where I'm going, tell me what data you need from me, 2 numbers, and tell me what I should expect back from you. You should be expecting JSON that has 3 items, A, B, and sum. It's that simple, guys. It's that simple. And as Anise correctly points out, this is where OOP starts to shine. The object-oriented part starts to shine. Show me how you do this in Jupyter Notebooks. I'll wait. As the kids say, I'll wait. This is where you really start seeing like, oh, okay, I really need to sharpen up my Python. Specifically, I really need to sharpen up my class and object design in Python, my OOP skills, right? Like this is, to me, this is where you're like taking it to another level. Like you're really, really working on some pro code when you start thinking like this. Denelson says, when we start having a large number of API endpoints, what are the best practices to keep them organized and easily accessible for management and maintenance? Yeah, good question, Denelson. 2 things come to mind. One, there really are no shortcuts other than, have a minimal number of endpoints, and then also use comments liberally. I use comments more than usual when I'm writing these types of API layers. Be very verbal about adding comments to these layers. Another thing, and if you guys have experience, you're welcome to put it in the chat, is keep in mind that I'm showing you the pattern for APIs, but this is the Flask implementation of APIs. It's completely possible that the other frameworks are a little bit more organized than this. That's possible, right? I don't know that because, like I said, I use Flask a lot. I'm a fan of Flask. But for all I know, Fast API is better at organizing code than this is, right? So we'd have to explore that also, Denelson, to fully answer your question, right? Having said that, it has to be a really special scenario when you're working on a project that has like a lot of endpoints that it becomes unwieldy, right? Like you'd have to be working on some really special stuff, So congrats to you if you do reach that point. But I've worked on stuff where it's a couple dozen endpoints, and that's a lot of code, but not necessarily unmanageable, right? What becomes more important is, remember how I said that versioning becomes a little bit more important? Well, if you have a team that's just working on API layer, and all they know is that they need to call calculate subtraction, there's no way of them knowing that they're working on the latest version of calculator.py, right? It's up to the communication between the 2 teams to be able to say, oh, okay, yeah, sure. Make sure you're pointing to this version of the class versus the other version, right? This or this method became deprecated in the class, but it's not deprecated on the endpoint side. So make sure you're calling the right version of the class method, not necessarily the endpoint, right? That's where it becomes a little bit trickier, Denelson. And to me, that's something that's not really dependent on the framework, whether you're using Django or Flask. That's more of a communication and organization issue, right? Because, just to kind of put an emphasis on that, once you name an endpoint like this, like you have a subtract endpoint, you basically don't want to change that, right? Because you've published this, right? You've published this in your documentation. You're going to have other people that are using your API, and they're going to rely on you having a subtract method. But what's called in that method, or in that endpoint, this method here, that's the important part for you internally as the team to track. To say, okay, whenever somebody, calls this endpoint, they're relying on us to provide this, this, and this. How you provide that, what version of that, what is the latest version that you're using for that, what is the most accurate version, whatever, that's up to you as the provider to track and stay on top of and say, okay, yeah, this makes sense, right? So that's where it gets a little bit more challenging, Denelson. But again, that's more of a people and organization problem than it is like a coding problem per se. So I hope that makes sense, Denelson. But great questions, guys. Great questions. All right. So let's do one more thing. I want to add an endpoint that has an HTML interface, right? Because we talked about it before about using templates and things like that. And the Django templates to me are a little bit complex, overly complex, overbuilt, if you will. But let's see how Flask handles them. Because I like working in the Flask templates. I think they're very interesting, very easy to use. Okay. Also, one of the things, here's another reason why I want to do that too. Because realize that right now, all of our returns are JSON data, which is okay, right? Because JSON is a nice, compact, easily transported format, easily understood in just about every language. But you don't have to return JSON. You can return text. You can return HTML pages, the templates, right? So let's do that. Let's look at this. Let's go back to our hello endpoint. And that's nice, it returns some information, right? A JSON message. But let's return a page here. Let's return like a home page here. Okay? So what we're gonna do is we're gonna ask for a new endpoint called home, and we're gonna ask it to return some HTML instead. Like, some stylized HTML. And again, I have ideas of how to do this, but who cares? We have an employee, right? Okay, so I think this is a reasonable prompt. We're gonna ask for a new endpoint called home. And I'm only doing that just to kind of separate out the code. We could be doing this in the existing hello endpoint, but we're gonna call it home, and we're gonna ask for HTML, and we're gonna ask for just a little bit of styling of the text. So let's see what it gives us. Okay, so that's expected. One of the requirements of most of these frameworks is that they want you to organize your directories in a certain way. So we have to add templates and home HTML. By the way, you should know that this templates, that's hard-coded. You can't call it anything else when you're working in Flask. I believe the same applies to Django. It has to be called templates, period. It can't be called anything else. And then home HTML is going to be the name of the template itself, right? So we're gonna start there. So we're gonna go to Visual Studio Code, and we're gonna add a new folder, and then we're gonna add a new file, right? Home.html, and let's see what code it gave us. So it's gonna update our app.py, which makes sense, right? Because we should be we asked for a new home, and there it is, home render template home HTML. So that makes sense. So let's copy that. I'm willing to accept that wholesale. Where is it? Let me close. Okay, so that's closed. API layer. We're going to go ahead and replace this wholesale. And then it should have given us home HTML, which okay, so here it is. This is home HTML. Copy cut. Do that. And yeah, it gave us some reasonable HTML. I'm assuming all of you are familiar with HTML. If not, this is what a basic HTML page looks like. It did some CSS at the top, some styling. And this is our body, and then it goes ahead and shows that. So this looks reasonable to me. So now, if we go to the home endpoint, we should see some HTML. Because remember, in the background, our server restarted, right? And there we go. That's our new output. So now, I think we're in a great spot, because now we are showing, we have an API that has a combination of data outputs and HTML outputs. Because you're going to want HTML outputs too, right? There's no reason for you to not host your own HTML pages, right? Maybe when you want to do a presentation for your stakeholders, you would do this. You would say, hey, we've been working on this algorithm and we cooked up this little sample HTML page because this will give you an idea of how you're going to access the algorithm. And now you go ahead and do something like this, right? So let's go back to Visual Studio Code. We have our new templates directory. All future templates are going to go in here. Right? In our API layer, we have this new home endpoint. And this time, we're not returning JSON. We're returning a render template. Render template is a function or a class within Flask. That's a Flask item. So in Django, I'm sure Django has its own version of that. But staying within the Flask framework, that's what it's called. It's called render template. And render template knows to always check in the templates directory and look for this file name, home HTML. So now we have home HTML that contains everything that we want to display. So again, coming back to the project management side of things, now we've enabled another person, another team to be able to work. Because now your UX team can start to work. Your UX team, you can say, hey, here's 5 templates that we're going to use in our app. We've created completely blank files or basic files in the templates directory. Go ahead and work on those while we work on the algorithm and the IT guys work on the API layer. So now you have 3 teams working together in parallel to develop the same app. Super critical way to bring your applications to market, right? And you're able to do that because you first started with the API layer, not the algorithm, but the API layer. Michael says this is just like Django. Yeah, Michael, I think you're right. I think Django also requires the templates directory. I'm pretty sure they share that in common, but I think that the Django templates tend to be a little bit more complex in what they require. And I think Django also requires additional directories, don't they? I thought it needed a couple of directories. But I like Flask. I'm partial to Flask because it's just simple. It makes sense to me how it wants it to be done. But if you want to use Django, if you want to use Fast API, go for it. You don't have to listen to me. I encourage you guys to do your own explorations, right? But yeah, Michael, I think you're right. I think they share a lot of similarities, Django and Flask. And Bottle too, right? Because Bottle is like a subset of Flask. What do you call it? A branch of Flask. Okay, so I think that I basically have hit all the different items that I wanted to share with you today. So if you have some questions, start putting them in the chat. But I hope that you can start to see how, one, the benefits of the API, right? Because we're accessing things that literally could have been done in any language. We're accessing it from a web browser, which means that it can be accessed on any platform, right? Mac, PC, doesn't matter. We're accessing it via IP address, which means that it can be accessed via any number of tools, utilities, right? We could be viewing this on a mobile app. We could be viewing this on a television, on an iPad. It doesn't matter, right? The endpoints are basically going to be open to the world, 24/7, accessed by anyone that you've authorized access for. And then how they get that information, how you generated that information, is of no consequence to them. The only thing they know is that when I go to sum, I'm going to get the return of 2 numbers. Great. That's all they really need to know. What else do they need to know besides that, right? And then here on the back end, we have enabled our DevOps people to help us with the API layer, because they can go out and figure how many web servers you need, how to distribute them, the load balancing, all that stuff. We've enabled our UX people to work within the templates directory. You can say, hey, look, here's the templates directory, have at it. Create whatever you want, however many pretty pictures and images you want, or whatever you want to do. Just work on the templates directory and you won't bother us. And then you, the data science team, are freed up to work in this class or whatever other classes you create. And you can go off and do your own explorations, your own algorithms, your own prediction statements or prediction functions, and say, hey, this is what we're capable of predicting. We've done our metrics, we've done our testing. This is the best possible answer that we have. Go ahead and feed this endpoint. Whenever called, whenever requested, right? So Denelson says, how would the documentation and client report look like, or how would it be structured? So Denelson, a good question. Basically, it would be kind of like a box, like a diagram, right? Let me think about this. You know what? Let me bring up. Can I do that? Let me bring up an example of how I would do it. Give me just a second. Yeah, so Denelson, I'm going to do this really quick and dirty. But basically, the documentation can be a series of boxes, a series of charts. And you would want one chart for every endpoint. So here is the endpoint name. And then you'd want the endpoint address. And then you would want the There's a lot of names, but you can just call it the input and the output. Right? So what's the endpoint name? Sum. What was the address? It was 127.0.0.1 sum. What was the input? A. That could be a float. And then the other input was B, which could also be a float. And then output is sum, which is also a float. So that's it. That's it, Dellison. You would want to do one of these for each input, excuse me, for each endpoint. This is usually enough to get people working with it. Like you would send this out to other developers, or you would publish this as part of your API documentation. And you would say here, oh, maybe you'd want to also do some sort of description, right? Like a text description. I didn't include that because, you know, I took it for granted that sum is kind of self-explanatory. But that's what you would do, right? Here's the name of the endpoint. Here's where you access it. Here's what we want from you. And again, they could be doing this in any language. You don't care. But this is what you need to, this is how you access it. So what you see up on the screen, Denelson, do one of those for every endpoint, and that's it. That's your documentation. Because also remember, guys, you are not sending this documentation to the executives, right? This is more of those tech team to tech team talks, right? Where you, the tech team on the data science side or the consulting side or whatever, would be talking to the client's tech team, right? Like that's where these conversations are happening. Like this documentation, you know, the executives really don't care about, nor would they understand it most likely. But that's all you really want to do. You just want to say, here's the address, here's what I want from you, here's what I promise to give you back, and then you know, you go off and make that happen, they go off and make that happen, and you're done. Right? But that's really the only documentation that's required. There's no coding examples, right? There's nothing like that, because the whole point is that they could be using any language, so you can't come up with a coding example in every language, right? I mean, it's really just kind of like a data interchange type of approach. Right? So yeah, great question, Denelson. The last call for questions, guys. But I think I've covered everything that I intended to. So if you want to take this work forward, go off and do some work on your own in Flask. Go off and recreate everything we did. Do it in Fast API. Do it in Django, right? It sounds like some of you have experience with Django. So maybe you want to go off and do it in that. You know, that could be fun, right? Go off and start exploring more OOP stuff. Right? Because I think, again, that stuff like today is where you start to see like, okay, wait a minute, I really need to understand object-oriented programming more. When you start looking at code like this, in the API layer, you should quickly start to see like, wait a minute, the last Python script I wrote was 200 lines. How am I going to put 200 lines here in this other bigger piece of code? It's just not reasonable, right? The code maintainability gets ugly real quick. You want to have this division of labor between the two classes and the different objects. You want that. I mean, not only is it more appropriate, architecture and design, it's just kind of like more convenient for you, right? So that's what I would encourage all of you to think about, kind of carry that work forward. If today was like drinking from a fire hose, that's okay, because again, this is the stuff that really isn't taught to data scientists. There's no school, there's like literally no school programs out there teaching you how to do this stuff, right? Maybe some computer science programs will teach you this, maybe, but not likely, right? They'll teach you object design, but not how to open up your API to the outside world, right? A lot of software engineers don't need that, but data scientists do, right? Because your algorithms are going to be used in something, right? So guys, I hope you found that beneficial. Really fun to think about these things because, you know, I enjoy kind of this API design type of stuff. It'll certainly become more valuable to you as you grow more into professional data science development. And again, as I said, if you guys want to show me how you can do everything of this in notebooks, I'll wait. Start doing more, you know, get away from notebooks, start working natively in Python, start working more from an object-oriented perspective, and start bringing more of that architecture design, architecture mentality to it. Because that's where we'll be when we are data scientists that are heavily aided by AI, right? We're not going to write the code, AI will. But we still got to decide where those classes go. When do we need a template? When do we need data output versus an HTML output? That's still us. That's still the human, right? That's still our creativity, our thought process, our experience, our interpretations of the client needs, so on and so forth, right? So, thanks so much, everybody. Really appreciated the time. As always, you know, please take care of yourselves, take care of each other. Tomorrow I will stream again. That'll be my last stream before the holiday break. But I always stream on Mondays in case you guys have questions about today. So think about it. And if you have questions, you know, I'll see you tomorrow, guys. All right. So until then, I'll see you next time.